So my teaching plan in the next semester, 2018, I'm going to teach the both database and operating system because it's my requirement to teach. And I'm going to offer the big data course, so those who are interested in the data or the database, so I think you can consider the big data system 651. So in the big data system, so we will learn how we are going to manage the big data. So mostly the relational database nowadays it's not up to the petabyte size data, but it's very popular to see the 100,000 petabyte size data in the company. So to manage it, we need to consider the different data structure and architecture that will be discussed in the big data system. Both regular and the online course regarding to the syllabus, it will be the exactly same identical. So then in summer or the fall semester, I'm going to teach you the NoSQL database. Also may be possible the data mining, depending on the department environmental situation. Okay, then those who are interested in the big data and data analytics concentration, so you can consider the database, the big data, NoSQL database, and the data mining. Then that will be shown on your transcript as a concentration on the big data and data analytics. So then rest of the semester we roughly have 5 more weeks. So 2/3 of the semester is already gone, and we have the other 1/3. So we will finish the I/O management pretty much the next 2-3 weeks before the Thanksgiving. Then after Thanksgiving, we will finalize the memory management. Meanwhile, you are going to do another big project, which is the portable file system. So that will be discussed the next class as well as the I think the next week, the Monday, we will after we cover the file system, then we will discuss about what is the requirement, how you can start your project. Okay, so then I think mostly over the Thanksgiving, so you can do your project. Okay, so we today we will cover the chapter 11, that is a file system, file system interface. And based on that, we are able to design the file system. So this is kind of a part of also your second project. For the undergraduate student, it's not required for the second project, but I strongly suggest to do your project for your extra point. It will be also very useful for your experience. Okay, so quickly go over what we discussed in last class. So last class we talked about what is a file. So a file is, as we discussed several times, is nothing but the sequence of bytes. But depending on how to organize such a byte, there are a variety of the file types. Okay, so who decides such a file type? In other words, a data structure. So sometimes the application program, sometimes the operating system, sometimes the user decide. Then that data structure is on the header file information, or sometimes specific application program, like the MS Word can read the file type of the DOC or DOCX. But if there's another application that can understand the specific data structure of the file, then they can open the file. Sometimes we call this comparable. So file. So file is nothing but file is not always the two-dimensional array or the XSS style or the document style. It's just nothing but the sequence of the data. Okay. For data, we have the data structure. It's a file. That is a file. Then the then which means we have a lot of files. So to manage such a file, to manage such a data in our operating system, we need something specific, the software. That will be the file system that we are going to discuss further later. So this is the simple record structure. So we can sometimes consider file has the file that has the number of records, especially when we manage the data. So sometimes it's considered as a line, fixed lines, variable lines, but that will be discussed more details in the database, the course. Okay? And mostly we are using the complex data structure, the complex structure of the file, so like the MS Word file, or the image file, or something specific data file. So those are the formatted documents, or the complex file. Okay. Then later, so today mostly we will talk about how the file is organized and how to access the file. And when we access the file, when we open the file, what happened, what kind of information we need to manage, the activity should be managed by the eventually file system later. So that is the first part of this chapter. Then the second part, once we have a number of files, like the millions of files, there might be problems, a lot of problems. So for our convenience, when we manage the number of files, so we will think about the different data structure. That will be the directory structure, or sometimes it's a folder structure by grouping such a file. Then, depending on how to organize such a directory, there are different types of the directory structure, like the single level, multi-level, or the tree, the cyclic graph, and the different data structure for the directory will be discussed then. So when we have this file and directory, these are the two main things you need to consider when you design the file system later. Okay? In the second project, you are not going to implement the directory structure. Instead, we are going to focus on the file structure, a number of files, how to manage such a number of files on our file system. Then plus we will a little bit talk about the access, because that file system will be accessed file. A certain file will be accessed by the many users, many applications, the many other programs. So we need to manage something permission, security. So which is managed by the access control. So we will see how to control such access permission in the general file system. So mostly three parts, but those are not very difficult concept. So each file has, as we discussed before, it's a data structure. So when we talk about the data structure, one of the popular data structure is the class. Okay. So in the object-oriented concept, so how to design, how to start your OOP, object-oriented programming. You need to understand real world, okay? We are the data, then investigate. So how to investigate? Like in the real object. So here's an object, here's an object, here's an object. By collecting a number of objects, you can define we need the data name, ID, address. So these are the variables to be managed in our data structure. Then you can define a class. Class consists of mainly two parts. What? Data and method operation that you can do. So data will be name and ID address. And the method will be like the change or the access. So through the method we can access or manipulate the data. These are the data structure. Then once we have the data structure like the class, student class, we can create an object. At that time, the object is slightly different from the object that we started with. Okay? The first thing that you consider is a real life object. Okay? By analyzing, by investigating the real life object, we can define certain data and the method, behavior. Okay? Then we can design the data structure that is a class. Using class, we can create an object. Object will be created in the memory. then will be available for others. These are the same thing for many of the data structure in computer architecture. Okay? So for example here, so we have the certain information to be managed. So how can we manage? So at that time we can define the file, okay? The data structure. So file has the attribute, it's the data that we discussed. So what kind of file name, file identifier, and type, and so on, and the truncate access. These are the data and the method, file attribute. Then finally using this file structure, we can create the student file, and so on. Okay? So this is a file attribute. Such an attribute information, header information can be accessed by the application. Like this is an example of the macOS. Or if you click the right click on your file in Windows system, you can see the property, then see such a file information. So these are the generic. So you can see the very similar the attribute information in any operating system. Okay, so for example Windows or Linux or the OS X, so it's mostly the similar the attribute. Okay, so what kind of operation are possible? This is kind of a method or the behavior that we can do with the data. So like for example, create the file, write the file, read the file, and so on. Okay, then among these, mostly the operation in the file structure is the last two things, the open and close. So we can open the file, then if that is already exists, we can access the file. Then if you are done any operation with the file, you can close the file. Then at that time, so this the open and close. Have we ever directly, explicitly used the open and the close such a method? Mostly not, because your application program, high-level programming implicitly include such a thing. Instead, each program, for example, provide the library or the method that you can use, or your application implement something function to open the file, to save the file, to close the file. Inside, they use such an open and close basically. However, if you are using the system library, the system library, also operating system provide such a functionality to access to create the file or to open the file. So like for example the app open or the app close. So this can be used. So in other words, if you design the operating system, you can think about if you design the file system, you can think about what kind of the file structure you are going to create. So if you decide to create your own file structure, you need to decide such the attribute as well as the operation on your file. Then finally, the other part of the file will be data. It can be image data, it can be the student information, it can be any kind of the data you can have. Then the next few things is kind of the little bit more detailed operation that is designed in your file operation. First, the open file. So when you open the file, what happened? So for example, one thing is, I open the MS Word file. Then I try to open the same file by double click on my Explorer. Can you open the same file 2 times? Yes, you can do that, but second thing will be read only. Until you change the name, you cannot actually modify such a data. It's a read only. Why such a thing happened? The file structure, they manage something information about your file. For example, each file can be accessed by modified by only one application or one user to avoid what? Synchronization issue. It's one of the way to avoid such a synchronization issue. But if you just read only or just open the file without the change, then you can open as many times as possible. So how to manage such a thing? That will be happened when you open the file. So first, when you open the file, so operating system, your file system specifically, keep track of each application, how many applications are using the file. Okay, so that will be later discussed. When you open the file, operating system manage the table for each process, how many files are created. It's a per table. There are two things. So when you open the txt file, so per the process, so there's txt file is the open. This one will be accessed. And if this process opened another file, and such a file is. And per file, okay, then for example, a.txt file is opened by the process number 10 and 11 and so on. Okay, so per file and per the system-wide, we are going to manage which process use each the file. This is very important to avoid such any synchronization issue, and also to share such a resource, the file resource, as much as possible. Then one thing is, so later, because I'm focusing on the file system a lot this semester, because your project is the file system. By the way, what is the file system? Data structure. It's a bunch of data structure to manage what kind of data structure? File data structure. So it manages a number of the file. That is the main job of the file system. So basically this is a software. Okay, like the MS Word, like the Explorer, and like any other application program, this is a software. Somebody develop and compile and sell this product, like the MS Word, and like any other application. So, file system is a software to manage this one. So, but have you ever started your file system to use? No. Instead, mostly this file system will be started when your system is started. So because of that, you may not realize. However, sometimes I mentioned about the big data system. Okay, actually, big data system, many of the big data system has their own file system. For example, you heard about the Hadoop. So it's the first time to hear about the Hadoop. Probably not. Most of the students heard about the Hadoop. Hadoop is what? It's a big data framework solution. Okay, then what's really the Hadoop is? It's actually file system, especially distributed file system. So when you start the Hadoop, it will actually start the distributed file system. And number of processes are running to manage such a thing. So this is a file system. So file system is not exactly same as your other application program, but mostly similar, the concept. So this is a file system. Okay, then, so suppose that I'm going to start explicitly the file system. Then what happened? This file system manage what? Number of files. But to manage the number of files, there are a lot of things you need to consider that we are discussing. For example, this kind of the process, open the file, or this kind of table is also part of the file system. Then this information will be, so what is this? It's a computer that we are talking about throughout semester. This is the operating system. So operating system has the file system. When you start this file system, actually how to manage. So this kind of information will be loaded into the memory. So it's a memory-based file structure. You can manage this information on the file system as a file also. But how many times this will be accessed? Many times to speed up. So we do better put such an information. So some of the information of the file system loaded into the memory. This is called the memory. The memory based file system. So many of the file system use such a memory. Use the memory to keep this data. So in the project, we are not going to consider this because it's a little bit complicated. Instead, we are going to use only the file. However, you can, like for example, NTFS. NTFS definitely knows, for example, the last class we talked about the hardware. For example, hard disk drive or the SSD. It has what? A number of what? Logical unit. I think I gave the homework last time, right? No? No? Nothing? Somebody say yes. I gave. Anyway, so it's a logical unit block. So we can number from the most outside 0, 1, 2, 3. Using this block, we are able to access the data. So, for example, NTFS understand that if somebody create a file, then the one or the many blocks will be allocated. Then they know that when the user access the file, eventually access this one. Okay, so if you implement the NTFS, you should be able to convert to such a different address format. However, in the project, the portable file system, we are not going to do such a thing. It will be high-level file system, which means on top of the existing file system. For example, if we are using Windows, it will be NTFS. If we are using the Unix file system, it will be EX2, EX4, something like that. Existing file system, on top of that, we will create the file system as a file. Okay? Then this file will be organized by what? Same thing, block. So we create, for example, if you create the 2K, so default file system, 2K, then my block size is, for example, the 512 bytes. So how many blocks you have? Only 4 blocks. So 4 blocks will be created. And this 4 block has all the information that we are going to discuss. Like for example, the open file table will be managed here. And later, which one is the free block? Which one is the occupied block, used block? So you will manage in here. But in real file system, this kind of information will be loaded into the memory for efficiency. But you don't have to consider such a memory base. Instead, all information will be designed here. So which means some of the students really confused. The main purpose of this project is not the programming, the skill contest. Instead, it's a design. How to design your file system. So I'm going to use the 512K block and the design how to use this 512K block, number of block to keep this information. First, the block will be used for the open file, and the second block will be used for this one. This will be more discussed later. But with such understanding, so it will be easy to understand what we are discussing today. Okay, then in addition to the open file, so we will see the more details in the next class. So what happens when you open the file, okay? So then, for example, these are the information when you open the file, when you are using the file, like the file pointer, where it's like the program counter in the CPU. So you always keep track of what is the next instruction, like the program counter. Similarly, so when I open the PowerPoint, so it always shows the last you use the slide number 10. Similarly, not exactly same, it has the pointer, which one is the next block to be accessed, and so on. And definitely how many the process are accessing this file. We will see more detail. There are two different types of access, like this one, which is called the lock. When we are using the locking to address the problem of the synchronization, so we can use the lock. Even though it's not perfect solution, we use a lock because it's simple. So there are two types of lock generally. One is shared lock. Shared lock means you can share the lock. Okay? How many? As many as possible. Okay? Then it is called the read lock. You can allow you already know, the read only. So if the process 3 user access the same file, the first one will be owner, the other will be read only. Okay? That means it's a shared lock. And another lock is exclusive lock, and only one process can write the data. Only one process. Otherwise, it will be the problem-based condition. So, in operating system, it also has to provide the two lock, shared lock, and exclusive lock. In the database, it's basically same idea, but it's more details. So, we will see in the database class, but this one has the such a shared lock and the exclusive lock. Those number of processes will be managed. You can count on your somewhere in your file system. Okay. Then the disk location, as I said, when a user accesses the file, you do not know where exactly the information block is located. Instead, your file system knows to access such a data. Okay. And permission, we will see also the permission. So there are two types of lock. One is a shared lock, another one is the exclusive lock. Exclusive lock is used for the write lock. Okay. This is an example of such a locking, file locking. So don't pay attention too much to the syntax. Instead, for your phrase in Java, you can use the file lock, the class, so you can define the shared lock and the exclusive lock. So you can physically, explicitly implement such the different types of the lock. Okay. Also, there are different, as we discussed last time, there are different types of the file. That will be, how can you decide whether this file is for the object file, whether this file is the text file, whether this file is a binary file? How do you decide the types of file? Extension is not always. Okay, extension is just for your convenience, especially in the operating system, the Windows. Windows use the 3 letters, for some 3 letters of the extension, but nowadays more. But that's for the convenience. Instead, it's in the header. The file type will be determined by sometimes the operating system, sometimes the application program is still specified in the header. Sometimes it's not explicitly, you don't know, but generally. So we can group like the file type, executable file, object file, and so on. So there are even the command in the Unix. There is a file command. Whether this is the well-known file type, like the data file, or the source file, object file, even the jar file, zip file. So file, if you are not, because the Windows doesn't require any the extension. Nowadays, even the Windows, you can create the file without extension. It's not a problem. But so if you create the file without the extension, you may not know. At the time, you can quickly the file, then file name, then it shows if that is well-known, the file type shows what kind of file type it is. I do not show. I think the last time I did, you can just file and the file name. If that is the directory, it shows the directory also. Okay. I'm going to skip this part. I already explained in the meantime. And also, when we have the file, so there are different types of. Eventually, we'd like to access the data in the file. That is our main purpose. Okay. So, title of this one is the chapter 10 through 13 is I/O management. So the idea of the I/O management is the computer system actually basically compute the data. Okay, so through using instruction, but those data are not in the memory because memory is expensive. So it's in the mostly file system. So eventually our I/O start with access the data. When there are two main types of the access method. One is, as you know, sequential. So we can check the data from the first byte and next byte, until we find the data. That is the sequential method. Benefit is easy to implement. So you can implement it's like the next pointer, the next IO. When we talk about this next is the address of the file, which will be represented by the block IO. Okay, so block IO. Then another method is sometimes it's called the random access, or sometimes it's called the direct access. When you know the address or pointer or block number, you can directly access the data. That is the direct. Most of the systems nowadays is a support. Most of file that support the direct access, random access. So I don't have to explain the detail. There is other types of method, sequential method and direct method. There are other types of method to speed up mostly, which is we are going to get the help of another data structure, that is index. So index is so if you have the textbook, so always I'm using the example of the textbook to explain about the concept of the index. It's the exactly same idea. So when you search the specific topic from the textbook, so you check the index, then find the keyword, then see the number of page, the page number, then we can find the data on the page, that specific page. At that time, the index is different from the contents. Okay, it's organized by keyword and number. Okay, then with the help of mostly keywords are sorted. It's alphabetical order, so we can easily means we can use a binary search. For example, I try to look for the lead. Then you can cut it in half. Then find whether this is the first half or second half. Using the recursive algorithm, you can find the data with the complexity log n. Right. So that is much faster than the linear search. Then even after you find the page number, then go back to your contents, you can apply the binary search again. So that is the idea of the index. So index is a different data structure. In terms of file system, index is also file structure. Okay. So with the help of, for example, like we have the index file, with the help of index file, I'm not going to explain how to organize the index, how to access this one. That's mostly discussed in the database class. Okay, so I think if you are taking the database, it's the same time simultaneously. So we will talk about the indexing today. So if you are interested, you can still remain in the seat. Then we will talk about the index today. So this is the data file. This is the index file. So another data structure. And then there are the variation of such an index file. One of well-known such an index, the file structure is called the ISAM file. ISAM file, even when I joined the first job, 1995, so longer than the 20 years old. Even at the time, the ISAM file was still used in the real application. ISAM file is an index, the sequential access method. File structure include index. So mostly index is separate from the data file, but the ISAM file actually include the index as a part of the header information. So whenever you access the data from the ISAM file, you access the header information that include